Hello everyone and welcome back to the Intermediate Algebra video lectures. Today we are going to continue learning how to factor quadratics, and specifically we're going to be factoring quadratics in the form of ax squared plus bx plus c, where a does not equal positive 1 and there is no greatest common factor. So the quadratics that we're going to be factoring today do not have a leading coefficient of 1, and there is no greatest common factor that you can factor out to fix that. And even if there is a greatest common factor, factoring it out will still not make the leading coefficient 1. So the steps to factoring quadratics like this are different than the steps that we covered when the leading coefficient is 1, like in the previous video. So you just have to keep in mind that you should always ask yourself, is the leading coefficient equal to 1 first before you do any factoring, because the steps are different if the leading coefficient is not equal to 1. So the quadratic will be in the form of ax squared plus bx plus c, where a is the number next to x squared, b is the number next to x, and c is the constant with no variable. So to factor quadratics like this, what you're going to do first is you're going to find the value of a times c. You're going to multiply the leading coefficient by the constant, keeping in mind that a number always takes the sign to its left, so ac could be negative. Then you are going to find a pair of whole numbers whose product is ac and adds up to b. So you're basically finding two numbers that multiply to ac and add up to the middle number b. So what you're going to do from there is you're going to figure out what those two integers are, and then you are going to break up the middle term into the sum of two separate terms using those integers that you found. So basically what you're going to do is you're going to find two numbers, lowercase a and lowercase b, whose product is ac and add up to b, and then you will break up the middle term into the sum of lowercase ax plus lowercase bx. When you write it like this, you will notice that the quadratic has 4 terms now. As soon as the quadratic has 4 terms, you can factor it by grouping. So after you have broken up the middle term, you're going to factor it by grouping. If you need a refresher on how to factor by grouping, please feel free to watch the video on greatest common factors and factoring by grouping. So what we're going to do is we are going to follow those steps to factor this quadratic here. So if you take a look at this quadratic, the leading coefficient is not equal to 1. And the coefficients are 2, 5, and 3. So there is no GCF here. So there is no GCF, and the leading coefficient is not equal to 1. So what that will mean is that you have to follow these steps. Now a is the number next to x squared, so a is equal to positive 2. B is the number next to x, so b is equal to positive 5. And c is the constant with no variable, so c is equal to 3. So what you're going to do is you're going to find the product of a times c first. So a times c, the first number times the last number, is 6. So then what you're going to do is you're going to find two numbers that multiply to 6 and add up to the middle number, 5. So what are two numbers that multiply to positive 6 and add up to positive 5? Well, two numbers that multiply to positive 6 and add up to positive 5 are 2 and 3. So what you're then going to do is you are going to take the middle term, this 5x, and you are going to break it up into the sum of positive 2x plus positive 3x. Now keep in mind the whole goal of doing this is to write the quadratic with 4 terms so that you can factor it by grouping. And if you remember with factoring by grouping, you always split it up into 2 groups of 2. And the first 2 terms especially need to have a GCF. So keeping that in mind, while it technically doesn't matter if you list the 2x first or the 3x first, you have to keep in mind that you are going to have to factor this by grouping. So you want to make sure that you put terms with common factors next to each other. So next to this 2x squared, you should really put the 2x right next to it. This way, the first 2 terms, which will go in a group, are going to have a GCF. And then the last 2 terms, the 3 and the 3x, are also going to have a GCF. It's not a humongous deal if the second group, the last 2 terms, does not have a GCF. the first two terms must have a GCF in order to get factoring by grouping to work. So you have to make sure that you have a common factor between the first two terms so that you can get factoring by grouping to even happen. So here's what we're going to do. We're going to, from here, leave the 2x squared alone. We're going to leave the plus 3 alone. Then I'm going to break up this middle term 5x into the sum of 2x and 3x, keeping in mind that we want to put common factors next to each other. So I'm going to put the 2x first, and then the 3x. Now that we have broken this up into 4 terms, we're going to now factor by grouping. So I'm going to put the first 2 terms into a group, and the second term, 2 terms into a group. And I'm going to factor a GCF out of each group. So factoring a GCF just out of the first 2 terms, there's a reason why we put the 2x next to the 2x squared, because the common factor between these 2 terms is 2x. So 2 divided by 2 is 1, 2 minus 1 is x to the power 1, and then 2 divided by 2 is positive 1, and then x to the power 0 cancels out. Then we're going to do the same thing for the next 2 terms. The GCF between 3x and 3 is positive 3. So 3 divided by 3 is 1, leave the x alone, and then 3 divided by 3 is positive 1. So from here, on either side of this central plus sign, there are 2 terms that contain an x plus 1, so I'm going to factor out a parentheses x plus 1 and put the leftovers in another set of parentheses. So out of this first term, when you remove the x plus 1, you have a 2x left over. And in the second term, when you remove the x plus 1, you have the plus 3 left over. And now this is fully factored. And remember, if you're not sure if at any point you did something right, or if you're not sure that, I could have messed that step up, or I don't think I did this right, you can always check your answer using distribution. I'm going to do this next one with you as well because we do have some negatives thrown into the mix. So if you take a look at this, you look at the leading coefficient is not equal to 1. And there is no GCF because we have 2, -1, and -6. Not all of the terms are all divisible by the same thing. So what we're going to do is we're going to have to find the product of A times C. We're going to take the first number 2 and multiply it by the last number -6, gives us an AC of -12. Then what we're going to do is we're going to find 2 numbers that multiply to -12 and add up to our middle number, -1. Well, 2 numbers that are fairly close together that multiply to 12 are 4 and 3. And remember, when the sign of the last number is negative, the larger of the 2 factors will take the sign of the middle number. So since the middle number is negative, the 4 is going to be negative. Because -4 times +3 is -12. -4 plus 3 is -1. So what we're going to do is we're going to go from here and we're going to break up this middle term, this -1x, into the sum of -4x and +3x. Keeping in mind that we need to factor by grouping, so we need to make sure that we put terms with common factors next to each other. So I'm going to leave the 2x squared alone, and I'm going to leave the -6 alone, and I'm going to break up this middle term, -1x, into the sum of -4x and +3x. So which of these 2 terms should really go next to 2x squared? Well, we should really put the -4x next to it because 2 and -4 do have a common factor of 2. And then I'm going to put the +3x next to the -6. Again, if the last 2 terms don't have a common factor, it's not a huge deal. You do need to make sure that the first 2 terms have a common factor. All right, so now that this is written with 4 terms, now I'm going to factor it by grouping. So I'm going to put the first 2 terms into a group, and I'm going to put the last 2 terms into a group, and I'm going to find and factor out the GCF out of each group. So the GCF between 2x squared and -4x is going to be 2x. So 2 divided by 2 is 1. 2 minus 1 is x to the power 1. Then -4 divided by 2 is -2, and then x to the power 0 cancels out. Then for this next one, remember if this third term is positive, you should be factoring out a positive. If that third term is negative, you should be factoring out a negative, And then what is the GCF between 3x and -6? Well, there is a common factor of 3. So 3 divided by 3 is 1. Leave the x alone. Negative 6 divided by 3 is negative 2. Then from here, these two have a common factor of x minus 2. And then I'm going to put the leftovers in parentheses. So in this first term, when you remove the x minus 2, you are left with a 2x. Then in the second term, when you factor out the x minus 2, you are left with positive 3. And then this is fully factored. So as long as the quadratic is factorable, if your leading coefficient is not equal to 1 and there is no GCF, this method is going to work. So I want you guys to try this one for yourselves. The leading coefficient is definitely not equal to 1, and our coefficients are 2, -7, and 3, so there is no GCF. So because there is no GCF and the leading coefficient is not equal to 1, you need to use the AC method. So I want you guys to go ahead, pause the video, and give this a try, and then resume when you are done working. All right, so if you multiply the first number 2 by the last number 3, you get 6. Now remember, we are looking for two numbers that multiply to positive 6 and add up to the middle number, which is -7. So remember, the only way that you can multiply to a positive is if the factors have the same sign. Either both of the factors are going to be positive or both of the factors are going to be negative. Now, in order to add up to a negative, the two factors need to both be negative. And if you tried 2 and 3, they don't work. -2 plus -3 is -5. So what other two numbers multiply to 6? Well, we also have 6 and 1. So -6 times -1 is going to give us positive 6. -6 plus -1 is going to give you -7. So what I'm going to do is I'm going to leave the first term alone. I am going to leave the last term alone. And I'm going to break up this middle term, this -7x, into the sum of -6x minus 1x. Keeping in mind the first two terms need to have a common factor. So next to the 2x squared, I really should put the -6x because 2 and -6 have a common factor. And that means I'm going to put the -1x next to the 3. So then from here, now that we have this written with 4 terms, we're going to factor by grouping. So I'm going to put the first two terms in a group, and I'm going to put the last two terms into a group, taking that minus sign with that 1. So the greatest common factor between 2x squared and -6x is going to be 2x. So 2 divided by 2 is 1, and then 2 minus 1 is x to the power 1. -6 divided by 2 is -3, and then x to the power 0 cancels out. Now for the second group, if your third term is negative, which it is, in order to get factoring by grouping to work, you need to, when your third term is negative, you need to factor out a negative out of the last two terms. Now, unfortunately, there are no other GCFs because 1 and 3 are just only divisible by 1. So at the very least, I'm going to factor a -1 out of the last two terms. So -1 divided by -1 is positive 1x. And then positive 3 divided by -1 is -3. So then from here, they have a common factor of x minus 3. So when you remove the x minus 3 out of this first term, you have a 2x left over. Then when you remove the x minus 3 out of the second term, you are left with -1. And now this is your fully factored final answer. I'm going to do this next one with you guys because we do have a GCF here. GCFs are something that will just pop up at random, and they will pop up without warning. I mean, I did warn you on this one, but on any exam questions or any homework questions, you may not always be warned if there is a GCF. But greatest common factors are something that you should always look for first, and if there are any greatest common factors, you should factor those out first before doing any other factoring. So if you take a look at 6x cubed plus 14x squared minus 12x, first of all, each of these numbers is all divisible by 2. So there is a GCF of at least 2 here. And in addition, x cubed, x squared, and x, each of these terms contains the same variable. So because each of these terms contains the same variable, there is also a variable GCF. And since the lowest power of x that appears is 1, the exponent on your GCF is also equal to 1. So what I'm going to do is I'm going to factor out that greatest common factor first. I'm going to factor a 2x out of here first before I do any other factoring. So 6 divided by 2 is 3, and then 3 minus 1 is x to the power 2. Then for the next term, positive 14 divided by 2 is positive 7, and then 2 minus 1 is x to the power 1. And then negative 12 divided by 2 is negative 6, and x to the power 0 cancels out. Now what's going to happen is this 2x that you have gone ahead and factored out, you're not going to do anything with it anymore, but don't get rid of it because it is going to be part of the final answer. So you're just going to leave the 2x there, kind of ignore it, and just kind of carry it along through the rest of the factoring, and then it will be a part of your final answer just hanging out in the front. But what we're going to do from here is we're now going to focus on what is in the parentheses. And we're going to factor what is in the parentheses. Now, in the parentheses, unfortunately, even factoring out the GCF didn't fix the fact that the leading coefficient is not equal to 1. So the leading coefficient is not equal to 1, and there's no more GCFs. We already took out the only GCF there was. So 3, 7, and negative 6 do not have a common factor that you can factor out. So because the leading coefficient is not equal to 1, we are going to use the AC method. So we're going to take the new first number 3 and multiply it by the new last number negative 6, which will give us negative 18. So we are looking for two numbers that multiply to the AC, negative 18, and add up to the new middle number, positive 7. So in order to multiply to a negative, the two factors need to have different signs. One of them needs to be positive and one of them needs to be negative. So two numbers that multiply to 18, let's start with 9 and 2. Now the sign of the larger factor is going to be the sign of the middle number. So since the middle number was a positive 7, the larger factor is going to take the sign of the middle number. So the 9 is going to be positive and the 2 is going to be negative. Because positive 9 times negative 2 is negative 18. 9 minus 2 is positive 7. So what we're going to do is we're going to leave the GCF alone, we're going to leave that first term alone, and we're going to leave that last term alone. And we're going to break up that middle term, that that positive 7x, into the sum of 9x minus 2x. Keeping in mind that you're going to have to factor this by grouping, so whatever you put next to the 3x squared does need to have a common factor. So 9x is going to have a common factor with 3x squared, so I'm going to put the 9x next to the 3x squared, and then I'm going to put the negative 2x next to the negative 6. Now throughout the factoring by grouping process, you're just going to leave that greatest common factor alone, and you're just going to focus on only factoring what's in the parentheses. So I'm going to put these first two terms into a group, and these last two terms into a group, taking the minus sign with that 2. So the greatest common factor between 3x squared and 9x is going to be 3x. So 3 divided by 3 is 1. 2 minus 1 is x to the power 1. And then 9 divided by 3 is positive 3. X to the power 0 cancels out. Then for the second group, because the third term is negative, you do need to at least factor out a negative. And 2 and 6 are both divisible by 2. So we're going to factor a negative 2 out of the last two terms. So negative 2x divided by negative 2 is positive 1x. Negative 6 divided by negative 2 is positive 3. Then from here, we have a common factor now of x plus 3. So we're going to factor out the x plus 3 and put the leftovers in parentheses. So when you factor an x plus 3 out of the first term, you have a 3x left over. Then when you factor out an x plus 3 out of the second term, you have a minus 2 left over. And that GCF that you took out at the very beginning, notice I never got rid of it, and it's just there. It's not doing anything, it's just there. And it is part of our final answer. So now this, with our GCF included, is now our final answer. Remember, if at any point you ever want to try a problem before I do it, just feel free to pause the video and resume when you are done working. All right, so for this next one, we have 3x squared plus x minus 2. You might notice that the leading coefficient is definitely not equal to 1. And there is no GCF here. We have 3, 1, and negative 2. So when there is no GCF and the leading coefficient is not equal to 1, you need to use the AC method. So we're going to take the first number 3, multiplied by the last number, negative 2, will give us negative 6. So then we are looking for two numbers that multiply to AC, negative 6, and add up to the middle number, positive 1. So two numbers that multiply to negative 6, well, two numbers that are fairly close together that multiply to 6 are 3 and 2. And in order to add up to a positive 1, since the sign of the middle number is positive, the larger factor is going to be positive. So positive 3 times negative 2 is negative 6. Positive 3 plus negative 2 is positive 1. So from here, what I'm going to do is I am going to leave the first term alone. I am going to leave the last term alone. And I'm going to break up the middle term into the sum of 3x minus 2x, keeping in mind which of these two should go next to 3x squared. Well, we should really put the 3x next to the 3x squared because they need to have a common factor. And then I'm going to put the minus 2x next to the minus 2. So we're going to put the first two terms into a group, and then we're going to put the last two terms into a group. So the GCF between 3x squared and 3x is going to be 3x. So 3x squared, when you take a 3x out of 3x squared, you're left with x. And then 3 divided by 3 is positive 1. X to the power 0 cancels out. Then, if your third term is negative, you need to factor a negative out of the second group. And both of these numbers are also divisible by 2. So I'm going to take a negative 2 out of the second group. So negative 2 divided by negative 2 is positive 1x. And then negative 2 divided by negative 2 is positive 1. Then each of these terms has a common factor of x plus 1. So I'm going to factor out an x plus 1 and put the leftovers in parentheses. So when we remove the x plus 1 out of this first group, we are left with a 3x. Then when we take the x plus 1 out of the second group, we are left with minus 2. And then this is going to be your fully factored final answer. So I'm going to give you guys an opportunity to try one of these for yourself that has a GCF. Now, a couple things to note here is, yes, there are a couple of different GCFs. You're going to have a numeric GCF and a variable GCF. And if the leading term is negative, I promise your factoring is going to be a lot easier if you factor out a negative GCF first. Now, there's other GCFs besides negative ones. You're going to factor those out too, but at the very least, the greatest common factor that you factor out needs to at least be negative. What that will do is that will change the signs of all of your terms, and it will make the leading term positive. And I promise your factoring is a lot easier if the leading term is positive. So I want you to go ahead, factor out the greatest common factor first, and then finish this up by using the AC method to factor it. All right, so the largest number that goes into all three of these is 4. And since the leading term is negative, we're going to make our factoring easier by factoring out a negative 4. Yes, they are all divisible by 2, but since they're divisible by a larger number 4, we're going to use the greatest common factor. And since all of these terms contain the same variable, there is a variable GCF here. And the lowest power of x that appears is 1, so the power on our GCF is going to be x to the power 1. So what I'm going to do is I'm going to factor out a negative 4x out of each term first before I do any other factoring. So negative 12 divided by negative 4 is positive 3. 3 minus 1 is x to the power 2. Then negative 32 divided by negative 4 is positive 8. 2 minus 1 is x to the power 1. And then positive 12 divided by negative 4 is going to give us negative 3. X to the power of 0 cancels out. So then from here, if you take a look at what's in the parentheses, remember the GCF you're basically done with. Don't get rid of it. Don't forget about it, but just don't do anything with it. You're then going to factor what is in the parentheses. So if you take a look at what's in the parentheses, our leading coefficient is still not equal to 1. And we already took out the only GCF there is, so we are stuck with this leading coefficient of 3. So because the leading coefficient is not equal to 1, we do need to use the AC method, and we're going to use our terms that are in the parentheses. So we're going to use 3, 8, and negative 3. So we're going to multiply the new first number 3 by the new last number negative 3 gives us negative 9. So we're looking for two numbers that multiply to negative 9 and add up to our new middle number positive 8. Well, remember, in order to multiply to a negative, the signs need to be different. So one of them needs to be positive and one of them needs to be negative. And since I gave you guys a few minutes to try this problem, if you tried 3 and 3, they don't work because positive 3 and negative 3 are always going to add up to 0. So when that happens, don't give up because you're not going to give up until you have exhausted all potential factors. Two other numbers that multiply to 9 are 9 and 1. So in order to add up to a positive 8, the larger factor needs to take the sign of the middle number. So positive 9 times negative 1 will give you negative 9. Positive 9 plus negative 1 will give you positive 8. So two numbers that multiply to negative 9 and add up to 8 are 9 and negative 1. So what I'm going to do is I'm going to leave the GCF alone. I'm going to leave that first term in parentheses alone, and I'm going to leave that last term in parentheses alone. And I'm going to break up the middle term, the 8x, into the sum of 9x minus 1x. Keep in mind that whatever you write next to the 3x squared needs to have a common factor with 3x squared, or your factoring by grouping is not going to work. So I'm going to put the plus 9x next to the 3x squared and the minus 1x next to the minus 3. So again, you're going to just ignore the GCF and you're going to use factoring by grouping to just factor what's in the parentheses. So I'm going to put those first two terms into a group and those last two terms into a group, taking the minus sign with that 1. So the GCF between 3x squared and 9x is going to be 3x. So 3 divided by 3 is 1. 2 minus 1 is x to the power 1. And then 9 divided by 3 is positive 3. And then x to the power 0 cancels out. Then for the second group, because this third term is negative, you at least need to factor out a negative. Now, there are no other GCFs between these two terms, so at the very least, we're just going to factor a negative 1 out of the last two terms. So negative 1 divided by negative 1 is positive 1x. Negative 3 divided by negative 1 is positive 3. So then from here, we're going to factor out the x plus 3 and put all of the leftovers in another set of parentheses. So in this first term, when we factor out the x plus 3, we have a 3x left over. Then in this last term, when we factor out the x plus 3, we have a minus 1 left over. And then this, with your GCF just still kind of hanging out in front, is going to be your final answer. So I want you guys to then try this next one. So there is no GCF here because if you look at 2, 13, and 15, there's no GCF here. And you may also notice that the leading coefficient is definitely not equal to 1. The leading coefficient is 2. So this is going to require the AC method to factor it. So I want you guys to pause the video, try this problem, and then resume the video when you are done working. All right, so we're going to multiply the first number 2 by the last number 15, which will give us an AC of 30. So we're looking for two numbers that multiply to positive 30 and add up to the middle number 13. Well, two numbers that come to mind right out of the times tables that multiply to positive 30 are 10 and 3. And since everything is positive here, we're not going to have to worry about negatives, thankfully. So 10 times 3 is 30, and then 10 plus 3 is 13. So what I'm going to do is I'm going to leave the first term alone. I'm going to leave the last term alone. And I'm going to break up this middle term into the sum of 10x and 3x. Keeping in mind that whatever you put next to 2x squared needs to have a common factor with 2x squared. So since 10 and 2 are going to have a common factor, I'm going to put the plus 10x next to the 2x squared and the plus 3x next to the 15. Then I'm going to factor this by grouping. So we're going to put the first two terms into a group. We're going to put the last two terms into a group. So the GCF between 2x squared and 10x is 2x. So 2 divided by 2 is 1. 2 minus 1 is x to the power 1. 10 divided by 2 is positive 5. X to the power 0 cancels out. Then the common factor between 3x and 15 is positive 3. So 3 divided by 3 is 1. Leave the x alone. 15 divided by 3 is positive 5. Then from here, we're going to then factor out a common factor of x plus 5 and put the rest in parentheses. So when we remove the 2x out of this when we remove the x plus 5 out of this first term, we're left with 2x. Then when we remove the x plus 5 out of the second term, we're left with plus 3. And then this is going to be our fully factored final answer. So I'm going to let you guys have a chance to work on this next one as well. So the easiest way to master this, I do promise, is to just do a whole bunch of them. So it may look like that we're doing just a whole ton of these problems because we are, because I promise the easiest way to master factoring is to just do a whole ton of practice problems. So I want you guys to pause the video and attempt this one and then resume the video when you're ready to check your answer. All right, so if you take a look at the numbers 2, 19, and negative 10, there is unfortunately no GCF here. And the leading coefficient is not equal to positive 1. So because of this, we're going to have to use the AC method. So we're going to multiply the first number 2 by the last number negative 10 will give us negative 20. So then we're looking for two numbers that multiply to negative 20 and add up to the middle number 19. So if you tried 4 and 5, those don't work. Another pair of numbers that and 10 and 2 also unfortunately don't work. But there is another pair of numbers that multiplies to 20, and that is 20 and 1. So again, sometimes the one in itself factor does end up working. So when you've tried the obvious ones like 4 and 5 and 10 and 2 and you're thinking, those don't work, before you give up, try 1 in itself. Now, in order to multiply to a negative 20, one of the factors needs to be positive and one of them needs to be negative. And when the sign of the last number is negative, the larger factor is going to take the sign of the middle number. So since the middle number is positive, the larger factor 20 is going to be positive, and the smaller number negative 1 is going, the smaller number 1 is going to be negative. So positive 20 times negative 1 is negative 20. Positive 20 plus negative 1 is positive 19. So what I'm going to do is I'm going to leave the 2x squared alone. I'm going to leave the minus 10 alone. And I'm going to break up this middle term into the sum of 20x plus negative 1x, keeping in mind that common factors need to be put together. The first two terms must have a common factor. It doesn't matter if the last two terms have a common factor or not. You can deal with that. The first two terms must have a common factor in order to get this to work. So I'm going to put the plus 20x next to the 2x squared, and then I'm going to put the minus 1x next to the negative 10. So here we go. I'm going to split this into two groups of 2. So I'm going to put the first two terms in a group and the last two terms in a group. So the common factor between 2x squared and 20x is going to be 2x. So 2 divided by 2 is 1. 2 minus 1 is x to the power 1. Then 20 divided by 2 is positive 10, and x to the power 0 cancels out. Then in the second group, there is no other GCF here besides -1, but since the third term is negative, you do need to factor out a negative. And because there's no other GCFs, we're at least just going to factor out a -1. So -1 divided by -1 is positive 1x. -10 divided by -1 is positive 10. So then there is a common factor of x plus 10, which I'm going to factor out. And I'm going to put the rest in parentheses. So when we factor the x plus 10 out of this first term, we are left with 2x. Then when we factor out the x plus 10 out of the second group, we are left with -1. And then this is going to be your fully factored final answer. So then I'm going to do this next one with you. So obviously the leading coefficient is not equal to 1. And if you take a look at the numbers 3, -2, and -4, there is no GCF here. So because the leading coefficient is not equal to 1 and there's no GCF, we do have to use the AC method. So when you multiply the first number 3 by the last number -4, you get -12. So what we're looking for two numbers that multiply to -12 and add up to the middle number, -2. Now, let's start with some numbers that multiply to -12. And remember, if you're having trouble, you can always do a little bit of trial and error. So two numbers that come to mind that multiply to 12 are 4 and 3. So in order to multiply to a -12, you could have a -4 and a +3. Or you could have a +4 and a -3. Now, do either of those add up to -2? Unfortunately, no, because -4 plus 3 is -1. 4 minus 3 is +1, so those are out. Now, what other numbers multiply to -12? Well, we have 6 and 2. So in order to multiply to a -12, we could have -6 and +2. Or we could have +6 and -2. Now, do either of those add up to -2? And unfortunately, no, because -6 plus 2 is -4. 6 minus 2 is +4. And then, just to make sure that we're thorough, we're gonna try the 1 in itself factor. So 12 times 1 is also 12. So in order to multiply to -12, we could have a +12 and a -1. Or we could have a -12 and a +1. Now, do either of those add up to -2? No, because 12 minus 1 is 11. -12 plus 1 is -11. And that's it. Those are the only numbers that multiply to 12. We have exhausted every single factor that we could possibly find. There are no other whole numbers besides the ones that we've already ruled out that multiply to -12. And none of them added up to -2. So I think it's probably safe to say that there are no integers that multiply to -12 and add up to -2. It's not possible. We've exhausted all of them. So since there are no numbers that multiply to -12 and add up to -2, this right here is not factorable. Let's try this again. There we go. So this polynomial is not factorable. Just like you can have prime numbers whose only factors are 1 in itself, you can have prime polynomials. Prime polynomials cannot be factored, so its only factors are 1 and itself. This is an example of a polynomial that is not factorable. There are no integers that multiply to -12 and add up to -2. So in this case, a not factorable polynomial is called a prime polynomial. And you are going to run into these once in a while, and you are going to run into these without warning. So before you give up, though, make sure that you have exhausted all possible factors, including 1 and itself. You might want to do that one as a last resort if you can't think of anything else, but try every other pairs of integers, including 1 in itself that you can think of, and if none of them add up to your middle number, it's probably a prime polynomial. So not all polynomials are factorable. I do want to put that out there and put that disclaimer. Not all polynomials are factorable. So these are two other examples of polynomials that are not factorable. One of them is x squared plus 9. When there is no middle term, you can assume that there is a 0x here. So because the leading coefficient here is equal to 1, you would essentially be looking for two numbers that multiply to positive 9 and add up to 0, which you can't multiply two numbers to a positive and have them add up to 0. The only way you're going to get them to add up to 0 is if they're opposites, and if the numbers have different signs, the product is negative. So that's why x squared plus 9 is not factorable. And then similar idea for this next one. Because the leading coefficient is equal to 1, you would essentially be looking for two numbers that multiply to 1 and add up to 1. There are no whole numbers that multiply to positive 1 and add up to 1, because the only two numbers that multiply to 1 are 1 and 1, which add up to 2. So this is not factorable because there are no numbers that multiply to 1 and add up to 1. Now, these are not the only prime polynomials that are out there. These are just a few examples, but just keep in mind that before you say, oh, it's not factorable, make sure that you've exhausted all possible factors and make sure that you are using the correct method that is appropriate for the type of problem that you're doing. So that is going to be it for factoring polynomials using the AC method. We are still going to be factoring, and in the next video, we're going to be looking at some special factoring cases. So stay tuned for that. Thank you all very much for watching this video, and I will see you in the next one. Bye-bye.